Four factors that influence the rate of a reaction are temperature, concentration, particle size, and the presence of a catalyst. Collision theory is the theory that molecules have to collide in a certain way with a certain amount of energy in order to form a new product. So the first reaction we're doing is going to demonstrate how a change in temperature affects the rate of a reaction. To do that, we're going to dissolve salt in some hot water, dissolve salt in some cold water. And once all the salt dissolves in one of these two glasses, come back. So it's been about 30 seconds after stirring the hot and the cold water, and as you can see, the hot water has dissolved almost completely as compared to the cold water, which has actually dissolved almost nothing. So the reason the hot water dissolved the salt so quickly has to do with collision theory. Because the temperature is hotter, it speeds up the speed of the particles moving around, and as a result it creates more collisions. And more collisions would mean more reactions that take place, hence dissolving the salt back. So the second reaction we're doing today is we're going to dissolve sugar in water, and the difference is between 1 teaspoon of granulated sugar and 1 sugar cube. And this will demonstrate how the difference in concentration affects the rate of reaction. So as you can see, the granulated sugar is dissolved much quicker than the sugar cube. One of the differences was that the water more easily mixed with the already broken form of sugar. Like the sugar cube is packed tightly, and before it can dissolve, the sugar cube has to actually break down into individual, basically the same form as the granulated sugar. Okay, so now we're just gonna mix some vinegar with baking soda. Now I'm just going to dilute the vinegar with water. So I'm going to pour some water in here. I'm going to put some more vinegar in here. So now I'm going to put the diluted vinegar into the baking soda and we'll see what happens. As you can tell, the reaction happens at a much slower rate and much less effectively. There isn't nearly as many bubbles, and it's because the water changes the concentration. Got our hydrogen peroxide and the detergent mixture here, and the water yeast mixture here. And now we're going to put the yeast in the dishwasher, and we'll see what happens. So here we have a reaction progress curve demonstrating the time the reaction would take taken with a catalyst and without a catalyst. And what the catalyst does is it speeds up the time of the reaction. As you can see here, the energy required to complete the reaction without the catalyst is much higher than it is